The Secret of Flight, a series of programs on aerodynamics. Program 5, Stability and Control. Your host is Dr. Alexander Lippisch.
Today, we want to talk about stability and control of an aircraft. You know, it is often said that if you have an engine with enough power, even you could fly a barn door. Now, I must doubt that. Well, I couldn't make the experiment with the barn door right in here because I fear the barn door is too small for this place. But I could probably take this cardboard as a model of a barn door. And we can try to fly this barn door model. And you will see how it flies. Well, I think the barn door does not fly. Even if I give him a push, it makes only erratic motions and falls down, but it does not fly. See, this is an important point. Something which moves through the air, we call it flies. And some other thing, we say it falls or it is thrown. What's the actual difference? When something flies, then we expect to have a steady motion with almost uniform velocity, and where this thing which flies keeps the same attitude all the time. Something which is thrown might change its attitude, it might change its course and do erratic motions. Well, I can explain it in a very simple experiment to you. See, I have taken from my desk calendar 2 pieces of paper. The one piece of paper is just this one. You see, when we let it go, well, it makes these erratic motions in falling down, as you see with any piece of paper, you know. Now, if you fold some part of this up so that you get a special position of the center of gravity and shape it a little bit different, then you can make it flying. You see here? That means, what do you need for flight? You need stability of the motion. And on the other hand, if somebody would be in there and he doesn't want now to fly this way and probably around like this little model does it, but he wants to go another way, or he wants to go up, wants to go down, then he has to have, besides of the stability, he has to have control. So what you need is stability on the one side and control on the other side. Now when you think, which of the two is the most important? Well, on vehicles, as we use them like a car or a bike, we actually don't have stability. We just control all the time the car to go straight on the highway, or we control, for instance, the bike by hand or shifting our weight. So if we have an efficient enough control, we could all the time keep this flying thing on an even keel. The problem is this, that while we are on the car, for instance, we have to control only one motion sideways. But if you are in an airplane, then you have to control 3 types of motions, since you have 3 degrees of freedom. See, you have the freedom to go up and down. You have the freedom to go left or right. You have the freedom to go rolling. That means turning in the direction of your axis. Therefore, since you have 3 degrees of freedom, you need 3 types of controls. And it would be pretty difficult for somebody now not only to control this, which is probably done with a stick on an aircraft, but to control the up and down motion and to control the roll motion, all in one time. Therefore, finally, we came to the solution that the best is to make an aircraft stable in itself, inherent stable, and then control just its motion from there on. But originally, most people thought that flying, this time gliders, since they didn't have engines as yet, you would just need to shift your weight. Shift it forward and backward so you would control the up and down. They never thought about the control of the roll. And the first people who ever conceived this idea that you need 3 types of control for 3 degrees of freedom were the Wright brothers. Now they said we must change the incidence of the wings, the outer wings, so that we can turn in rolling over, because when we make a turn, then we have to bank against the centrifugal forces, which would throw us out. So first they thought the easiest way to do it would be probably to make a mechanism so that the wings could tilt and each wing would have a different angle of attack than the other one. But this was mechanically too complicated, would have taken too much weight. So they came to a better idea and said, why we don't take the biplane type and twist the whole frame. See, I have here a simple model, actually a replica of the first kite model which they tested. And see, they did not have any bracing across in here. They are just bracing in front, bracing at the back. And in this way, when you now make wires over rolls which are actuated by the pilot, then you can twist this without changing its strength. You see? And this type of warping the wings, they used all the time on their gliders. Now, I have here a very nice model of their 1902 glider. Actually, an exact model as the glider looked like. And we have even in here built in the controls as they used them. This is, now the pilot itself lays down on this lower wing and has in its hand the elevator control, which is this one. You see it move? So he pulls back and the thing goes up. Now he has a cradle where he lays in, and when he shifts this on left or right, then the whole wing warps. I hope you can see it. This warping is actually not very much what you need there. You see, when I warp it this way, then this angle is smaller, while this angle is larger. But they met in this way one difficulty. The moment you warp, for instance, this so that this angle is smaller and this is higher, that means that the plane would roll over this way. Then, due to the higher lift which you have here, you have more drag. And this more drag would actually try to turn the plane against the rolling. Therefore, they used, in addition to this wing warping, they used a rudder which is directly connected with the wing warping, so that when you push this wing down and have here more lift but also more drag, the rudder would counterbalance this more drag by turning the aircraft in this way. This very intelligent method of controlling an aircraft was actually the solution to the invention of the first flying machine. Now, most people would think that such a control in front for pitch, that means for longitudinal motions of the aircraft, would not be stable. You had to control all the time. Actually, that is not so. You can make an aircraft flying stable in pitch with an elevator, as we call it, in front or at the rear. And in both cases, you can obtain stability of flight. As I can show it you here. See, I have here a little tiny, flimsy model where I have the additional horizontal surface, the so-called elevator, in front. And you will see that this flies very nice and stable. You see? Now, if I take this wing and just turn it around, like this. You see, I have some clips down there, which I can push on this little stick. And then change the center of gravity by putting some little weight in front. So, and if I have it now adjusted right, I think it should be, then you can fly it this way. You see? That demonstrates very simple that you can stabilize for pitch stability either with the surface at the rear or with the surface in the front. The main principle of this stabilization is this. The surfaces which are in front have to have the higher specific loading all the time. That means if you have a wing, for instance, which has 30 pounds per square foot wing loading, and you fly with an elevator in front, then the elevator in front has to have more than 30 pounds, let's say 45 or 50. If you have it in the rear, then you have to have less than 30. That means probably 15 or probably even nothing. This is the system of pitch control. And even if you have only a wing, a flying wing, you do still the same thing. See, this is the model here. Now, the surfaces in front are the surfaces at the center. The surfaces at the rear are the surfaces on the wing tips. Therefore, you have to have less loading on the wing tips than you have in the center, which you establish here by just warping this wing, as you see it here. When you look from the side, here we have a much less angle of incidence than we have at the center. And you will see it certainly flies nice and stable. See, there it goes. Now, at our conventional type of aircraft, we have now established the pitch control by surfaces at the rear, which is in many ways more practical. You have to have a long fuselage, and you have practically no loading on the surface, on the elevator surface, makes it more sensitive in flight. And I have here a very nice little model where we now can explain all the method and all the system of controlling an aircraft as it is today. You see, this is the seat which is open here. Let's say it looks like a glider. You sit here and you have this stick in your hand and you have your feet on the rudder bar. Now, with the stick you control with forward and backward motion the elevator, which is now a flap on a fixed surface which we call the stabilizer. You see, when I move this back, you see, then the flap goes up. When I move it forward, the flap goes down. Now, if I move this stick sideways, then I move the so-called ailerons, which now replace the old method of wing warping as it was done with the Wright brothers airplane. Since we have now stiff wings and we fly with much higher speed, which is necessary then to have stiff wings, then you couldn't warp these stiff wings. It would be very difficult. Therefore, we have a hinged flap on the outer part of the wing and move the hinge flap instead of turning the whole wing. And you see, when I move this stick now sideways to the left, then the left one goes up, the right one goes down. You see, this way. Now, if you fly this aircraft and you fly through gusty winds, what have you to do? You see, you just do nothing, then keep the stick in a vertical position. Then you do the right motions intuitively. You see, if a gust hits our aircraft and pitches it up, well, then I keep the stick straight up and my elevator is down, so it would lift the tail back. If it would go this way, it would push the tail down. If I would be banked by a gust from the side, then due to the banking and keeping my stick straight, this aileron is up, pushes the wing down, this aileron is down, pushes the wing up. On the other side, if I want now to move the aircraft around, then I have to do just as if the stick would be fixed on the aircraft and I want to move the whole aircraft with the stick. So if I want to go, for instance, into a left-hand bank, then I would take the stick and want to move it this way. The moment I do this, I lift this aileron up, this down, and the left bank is there. If I want to turn it, then I have to use combined rudder, which I have on the feet. That means I make a left turn, then I push the left foot forward and push the stick over to the left-hand side, and there is my turn, as you see it here. You see, this system is actually very simple, and you can conceive it intuitively. You don't need to think about it, and this is important to fly, because when you fly, you have to think on other things, and you're controlling which you do without thinking that you do have to do this. You do it just intuitively. Now, a large aircraft, as we have it now, wouldn't be very easy to be controlled by hand, because these surfaces have quite some pressure on it, and therefore we need some help to move the surfaces. So we have servo mechanisms and servo motors in between, which are controlled by the control itself or are controlled by an autopilot. This autopilot I can show you. You see, at what we conceived here and what we have shown is that when you fly through disturbances, the only thing you have to do is hold the stick straight up. Keep it always in a vertical position. If you do this, then the aircraft would by itself do the right motions. Now, to show you a simple model of the system of an autopilot, I have here a little arrangement with a free gyro in it. That means this gyro is on two gimbals. It can move forward and backward and sideways by itself. And when you wind it up with a little electric motor, and down here is a big wheel which makes actually the gyro, we have then an artificial stick, or what we could call also an artificial horizon. So if I now move this model all around, you see, the gyro keeps this stick all the time straight. And this system of a free gyro is the heart of an autopilot as we have it in the large aircraft. We use it also in the same way for having an artificial horizon so that the pilot can fly without any visibility. You connect this gyro with little wires so that he gives signals to servo motors which then operate the controls. You see? You shouldn't upset it. Now, to show you the action of the control system as it affects the flow, we have some models in our smoke tunnel. And at first I want to show you the action of a usual elevator or pitch control system. You see, I have here a model where the wing itself is not attached to my controls. I can only move this little flap back there, which actually is the same as an elevator flap. And you will see that I will be able now to turn the whole wing just by moving this flap. Let's put it back into the tunnel. So, and close the window. And when I now turn the blower on, I can demonstrate to you how this acts. You see, I have here this one control wheel where I can now turn the elevator up and down. You see, when we have now the wind going and I turn up, elevator up, then we increase the angle of attack. If I turn it down, I decrease the angle of attack of the wing. And I can do any adjustment of the attitude just with this little flap. If we now turn the smoke on, then we can even see it with the streamlines around this simple aircraft model. You see? Now I decrease the lift. Therefore, our stagnation point sits up here. We have practically no lift. I turn it up and the lift is increasing. You see how much curvature we have up here and how high the velocity gets on the upper surface where we have sensor suction. Another thing, it's interesting to see here, the change of the attitude changes not only the field behind the model, but the whole field. And it reacts for our eye instantaneously. Now I have another model in the tunnel which represents the aileron system. That means just a simple wing section with a flap back there, which I can also move with the controls. And if we take this model out and put it in, I will demonstrate to you that such a flap works the same way as if you would change the angle of the whole airfoil. Because when you move the flap down, actually you make more camber, and then the angle of attack is this way, while it was before this way. So you increase the angle of attack and you increase the camber, and in this way you increase the lift, or you decrease the camber and decrease the angle of the attack, and then you have down lift, or practically negative lift. So if we put this in there and see it with our smoke lines, then we can at once observe the action of a flap as it is used on ailerons and certainly also on the elevator or on the rudder, in this way on the symmetrical section, while this is the wing section. Now let me adjust this. You see, I have to move both wheels when I want to change the angle of attack. And when I move only this one, then I can turn the flap itself. Now let's have some wind on and some smoke. This would be, for instance, a position of normal flight. You see, if I now turn it down, we have much more lift. If I go up, we have practically no lift. And you see also again how instantaneously the whole flow field responds to such motions. The motion is also the same if I have a larger angle of attack. The next time we want to talk about the propulsion systems which we use on aircraft. And I want to show to you, just as an introduction of this program, a picture which we took long time ago of a jet taking off. It's actually taken in 1941 of the experimental high-speed aircraft, the 163A, which I designed in way back 1938. You see, with these modern propulsion systems, we could have a very high performance, and actually we flew with this aircraft in 1941, 630 miles per hour. Now, I will also show you several models and other arrangements in the wind tunnel and here to explain to you the system of propulsion as with propellers and jets and things like this. For today, goodbye and auf Wiedersehen.
You have just seen Stability and Control, the fifth in a series of programs explaining the secret of flight. Your host has been Dr. Alexander Lippisch, Director of the Aeronautical Research Laboratories of the Collins Radio Company. This program was produced for the Educational Television and Radio Center by the State University of Iowa.